We have learned the acceleration in our previous video. In this video, let's learn the acceleration conceptually. We will also cover the methods to calculate the displacement by plotting the velocity against the time. Acceleration is rate of change of velocity with time. Let's say, car is traveling with velocity of 3 meters per second. So in 1 second, car will travel 3 meters. Now after time, its velocity is found 9 meters per second, so the velocity has increased in some time duration. That is nothing but the acceleration. The speed has increased from 3 meters per second to 9 meters per second. Acceleration is also the vector quantity like velocity. Both the magnitude and direction are known. So, how to measure the acceleration? It's the ratio of change in velocity divided by change in time. What is the unit of velocity? Velocity is measured in meters per second, and time is measured in seconds. So acceleration would be meter per second divided by second. So unit of acceleration is meter per second square. Let's imagine a ball is traveling with zero acceleration. Zero acceleration means there is no change in velocity. So we can say the velocity is constant. So whenever a body is moving in particular direction and if acceleration of the moving body is zero, then its velocity shall be constant. Now, let's say a ball is moving with constant velocity of 5 meters per second. A ball would travel 5 meters in 1 second. So, if we plot the graph of velocity against the time, on x-axis, there is time in seconds and in y-axis, there is velocity in meters per second. So for constant velocity, the graph will be horizontal line drawn from the mark of 5 meters per second. Let's say the ball has traveled for the time duration of 8 seconds. If we have to calculate how much distance the ball has traveled, then we can calculate it by simple formula, that is, velocity is equal to displacement divided by time duration. So here, displacement shall be equal to velocity times the time duration. Here, velocity is 5 meters per second and time duration is 8 seconds. So, displacement shall be 40 meters. We can calculate the same by plotting velocity against the time. Here, velocity is 5 meters per second and the time duration is 8 seconds. Let's try to find out the area under velocity graph for the time duration. So here, we have to find out the area of the rectangle. Area of rectangle is product of length and height. Here, length is time duration, that is 8 seconds, and height is velocity, that is 5 meters per second. So area shall be equal to 8 into 5. Area is 40. This is nothing but the displacement. So we can calculate the displacement by calculating the area covered by velocity against the time duration. Now, let's say a ball is moving with acceleration of 5 meters per second square. Acceleration is change in velocity divided by change in time. Change in velocity is meters per second. Let's say initial velocity be 5 meters per second. What would be velocity after 1 second, as the acceleration is 5 meters per second, per every second? So after 1 second, the velocity would be 10 meters per second. After 2 seconds, the velocity shall be 15 meters per second. After 3 seconds, the velocity shall be 20 meters per second, and so on. Now, let's try to find the displacement when there is some constant acceleration. Let's say a car is moving with velocity of 5 meters per second and there is acceleration of 1 meter per second square. Time duration is 3 seconds. Let's plot the graph of velocity against the time duration. Velocity on y-axis and time on x-axis. Initially the velocity is 5 meters per second. So let's start with the marking of 5 on y-axis. As the acceleration is 1 meters per second square. So after 1 second, the velocity would be 6 meters per second. The velocity after 2 seconds would be 7 meters per second, and the velocity after 3 seconds would be 8 meters per second. So, let's draw the line from 5 to 8. Here, we can see the slope drawn is actually the constant acceleration. Now, let's calculate the area under it. So draw the line from acceleration of 8 meters per second square to 3 on x-axis. The total area shall be equal to area of triangle plus the area of rectangle. Area of rectangle is product of length and height. Area of rectangle is product of 3 and 5. So the area of rectangle is 15. Area of triangle is length times the height divided by 2. Here, length is 3. Height is final velocity minus initial velocity. So height is 8 minus 5, that is 3. Area of triangle is 3 into 3 divided by 2. Area of triangle is 4.5. Total area is addition of area of rectangle and area of triangle. So total area is 19.5. That is nothing but total displacement. Before we calculate the displacement by the formula, let us understand how to calculate the final velocity by using simple concept which we have learned. So, final velocity is equal to initial velocity plus product of change in time and the constant acceleration. This something we have already learned in this video only. To arrive at the velocity after each second, we increase the value of velocity by the value of constant acceleration. So it is product of time and acceleration. So, initial velocity vi plus delta t into constant acceleration is equal to final velocity. From this graph, area of rectangle plus area of triangle is the displacement. Area of rectangle can be written as initial velocity vi into time duration delta t. Area of triangle can be written as final velocity vf minus initial velocity vi multiplying by time duration delta t into half. Let us rearrange it by taking delta t as common factor. So, delta t into in bracket vi plus vf minus vi divided by 2. So, delta t into in bracket vi plus vf by 2 minus vi by 2. So, delta t into vi by 2 plus vf by 2. And so, delta t into vi plus vf divided by 2. Vi plus vf divided by 2 is nothing but the average velocity as the acceleration is constant. So equation becomes, delta t into average velocity v is equal to displacement s. From this equation, let's find whether the displacement is equal to the area calculated by plotting the graph of velocity against the time duration. So displacement is equal to product of delta t and average velocity. Delta t, that time duration, is 3 seconds. Average velocity is initial velocity, that is 5 meters per second, plus final velocity, that is 8 meters per second divided by 2. So, average velocity is 5 plus 8 divided by 2. So, average velocity is 13 divided by 2. So, it is 6.5. Let us put this average velocity in formula of displacement. So, displacement is equal to 3 into 6.5, that is 19.5. This is exactly the value which we have calculated by finding the area. Subscribe Extra Class Academy for more educational content.